Hello ladies and gentlemen, welcome back to math. Today we're going to continue working with isotopes, okay? Today we're going to start seeing a little more of that shift we covered last class. If you guys remember, last class we talked about a little bit about H and K. If you guys remember, well, H is your X, K is your Y, meaning that depending if H was positive or negative, it was going to determine which way you moved, left or right. Remember, if it's negative H, you move to the right. Positive H, you move to the left. The same with K, if you guys remember from previous concept. If it's negative K, you shift down. If it's positive K, you shift up. Okay? We also talked about the parent graph, which was f of x equals 1 over x. Okay? That's your parent graph, meaning that x has to be 0 for your isotope. Today we're mostly going to focus on H and K. Okay? Notice that, make sure you, well, first of all, let's make sure you write all this down on your notes. All right, now that you have it on your notes, we can actually start with today's assignment or concept. The problem we're going to deal with today is f of x equals 1 over x plus 1. Okay? Notice that if you guys remember, in order to find our isotopes, okay, our vertical and horizontal, in order to find our vertical, remember the bottom has to be equal to 0. And if to find out if we have any horizontal isotopes, if you guys remember from the previous concept, okay, or the previous video, in order for the graph to have a horizontal one, you have to have a bigger number on top than on the bottom. Since in this case, it doesn't really happen, you really don't have a horizontal one because there's no x on top. Okay? If we were to put 1, it would be x to the 0 power, which means that x to the first is still bigger than x to the 0. So there's no horizontal isotope. We know there's a vertical one because we have x on the bottom. If you guys remember, by just focusing on your x over 1, our isotope in this case is at 0 because x equals 0. Because remember, if you had x plus 2 or any other number, you had to equal it to 0 to find the isotope. In this case, since there's no other number next to it, we can already assume it's at 0. So we know our isotope is at 0. So we're going to make our little isotope there. Now that we have that, it says that our graph, okay, if we put in the parent one, for this graph, we only need this first part for the parent. Meaning, we have 1 over x. What we're going to do is, notice that we have numbers here on our x-axis, right? We have numbers there. We have 1, we have 2, 3, -1, -2, -3. When that happens, is you're going to pick a few points on each side of the isotope, okay? Last class we just drew them in, okay? Today, if you guys remember, for the chart, we're actually going to plug in some numbers. So in our chart, there's just another color here. we have x, we have y. If you guys, like I said, we're going to use 2 on each side, okay? We're not going to get all crazy with it. We're just going to choose 2. We're going to choose 1 and 2, but we're also going to choose -1, -2. So -2, -1, and then on the other side, we're going to use 1 and 2. So the way you graph it is, we have -2. We plug it in for our x. So this graph becomes, if we're only dealing with the parent one, we're not going to worry about the one yet. If we had just the parent graph, we would have it at, if we plug in -2 here, this becomes -1/2. Okay? So at -2, our y, because f of x equals 1/x. Now f of x equals -1/2 for 2. So you have -1/2, or if you want to do it this way, -0.5. Okay? If you're better with decimals, that is fine. Okay? Either one is correct. Now we're going to plug in 1, -1 in this case. -1 divided by 1 is -1, because it's positive and negative. -1. So if we were to graph our first one, which is on the negative side, because remember we use the 2 negative numbers, we would have -2, start off with the -2. So -2 and -1/2, or half, should I say. So we're going to go down half, because remember, we have -1, -2, so in between 0 and -1, halfway, we're going to plug in our point at -2. So about halfway. Now that we have our point there, we're going to use the other one, -1, -1, -1, -1. We make another point there. If we connect these points, our graph looks like this. Okay? Maybe it's not, I missed the points by a little, but that's okay. This is not art. If we use positive ones, notice that we have the same exact points. We have +1, 1/1 is just +1, 2 is +0.5. So we do the opposite on the other side. We have 1/1, which in this case we go up 1 and +1, and then we go 2 and then halfway. And then we do our little graph, okay? That is why on the previous video I did one going one way, the other one going the other way. That's the way they run, because they cannot pass the isotope. Those are the parent ones. Keep in mind, we forgot about this one, or at least we didn't forget. We pushed it aside for now. We did our parent graphs, but the original graph says that the parent graph shifted, okay? Hint, hint. The equation, if you guys remember from the previous video, it was, let's use another color here, the color we can actually see. The equation we did last class was f of x 1/x minus h and then plus k. Okay, that was the equation from last class. We really didn't have an h in this problem because there's nothing next to the x. So the line, or the lines should I say, because there's 2, didn't move left or right because there was no shift for h. But we did have a k, which in this case is, since it's positive and the equation is positive, we only need the 1. Okay? If the equation was negative here and you had positive here, then remember the opposite, which was -1. Since they're both the same, we only need the 1. So it tells us that both of these lines shifted. Hint, hint. Did it shift up or down? Since it's +1. They shifted up, right? Because it's positive. So all these points are going to go one more dot up. So if we have 1 there, we go up 1, we keep it on the x the same, Because remember, they didn't move left or right. They just went up 1. Since the point was at 1, 1, now it's at 1 and 2. The same with the other one. The other point on 2 and half, now we went up to 1/2. So our new line shifted 1 up. The same with the other one. It shifted 1 down. What's that? 1, so it became a 2. The other one's like halfway. So our line, in this case, should I say, my bad, it shifted up. So we went from 1, 1, we went to 1, we went up half, so it shifted up. Whoa, I went over a little. So it shifted up 1 on both sides, okay? They both shift. And that's what we're doing today, okay? We're focusing on the shifting part of the equation, okay? Mostly today. You could have also done it all together, where you could have find the 1/2 plus 1. In this case, for example, if we would have had negative 1/2, we could have done plus 1, turn that into a fraction, and you could have worked that out that way as well. But my advice to you guys is, if you have to do the parent graph first, it makes it a lot easier for some of us that are a little more visual, okay? So if you need to do the parent one first, and then do the shift, it makes it more easier for you that way, that is fine as well, okay? Just tell me which one's which. Tell me which one's the parent one, which one's the one you shifted, okay? So here is your assignment for today. All right, guys, your assignment for today is, you have f of x equals -2 over x minus 2. Okay, hint, hint. Is it H? Is it K? Are we shifting left, right, up, and down? Okay, hint, hint. Remember, if it's actually x, it's a specific variable. And your second one is f of x equals 1 over x plus 3 plus 2. Okay, that's your second one. Make sure you send me your answers as soon as you're done watching the video. If you have any questions, guys, let me know. Okay, I'm here to help. If you need me to do a Zoom session with you, that's fine. Just let me know when. We can do one, so we can go a little more in depth with it. So make sure you submit also a picture of your notes, and I'll be here waiting for your email.